Typically, we like to factor if we can because it's usually faster, easier, but factoring isn't always 100% guaranteed to work. Some quadratic equations or quadratic expressions just don't factor. So then we usually, if we can't factor it or can't factor it easily, we typically then default to using the quadratic formula. So let's talk about factoring. I want to solve this equation, x squared plus 7x plus 12 equal to 0. And I will mention that saying solve this equation is equivalent to saying find the zeros or roots or intercepts of this expression. So if you're finding the zeros of x squared plus 7x plus 12, you're finding the solutions to x squared plus 7x plus 12 equals 0. Or if you're finding the roots, right, you're finding where, again, the thing is equal to 0. Or if you're finding the intercepts, if you graph x squared plus 7x plus 12, or I should say, if you graphed the parabola y equals x squared plus 7x plus 12, it would have x-intercepts that were whatever the solution to this equation is, because the x-intercepts are where y is equal to 0. So how do we solve an equation like this? Well, I like to factor. And there's probably like 2 or 3 good methods of factoring. And they kind of depend on what you're faced with. In this problem, when I should, let me turn up the light here. So in this problem, it's relatively easy because the coefficient of x squared is 1. So if the coefficient of x squared is 1, you can always try to do the following. We're going to look for 2 numbers that multiply to 12 and add up to 7. So we want numbers that, and you know what, people use people use this like diamond method or grouping. I've never been good at that. So I'm just going to say I want to multiply to 1 times 12. And I want to add up to 7. That's what I'm looking for. So what are 2 numbers that fit the bill? 2 numbers that fit the bill are 3 and 4. Now, when the leading coefficient is 1, or when the coefficient of x squared is 1, it happens really easily. You can write x squared plus 7x plus 12. And I'm going to give myself some space because I'm going to show the grouping that someone mentioned. But you can kind of jump straight to the end and say, oh, this is just x plus 3 times x plus 4. And that's always going to work if you can find numbers that multiply to 12 times 1 and add to 7. It's always going to work. It's just those 2 numbers like that. It's a little bit different if your coefficient is like 2 or 4 or 6 or something that's not 1. So here's what we do if we're factoring by grouping. We're going to write that middle term 7 as 3 plus 4. Or really, I'm going to write 7x as 3x plus 4x. So write this as x squared plus 3x plus 4x plus 12. And then I'm going to factor by grouping. I'm going to write the first 2 terms, I'm going to factor as much as possible. I can factor out an x. I'm left with x plus 3. The second 2 terms, I'm going to factor out as much as possible, which is a 4. And now here's the kind of the thing that should always happen if you're factoring by grouping. The leftover part should be exactly the same as the leftover part here. If it's not, you can't factor by grouping. The factoring by grouping should always work in this kind of situation when you're trying to multiply to 1 times 12 and add it to 7. So then from each of these, we can factor by grouping again. We can factor out an x plus 3, and we're left with an x plus 3. And then from each of these, there's an x here and a 4 here. So we have an x plus 4. I guess I didn't need to give myself all that extra space. Oh, well. I just wrote it again. This seems kind of so. Oh, well. So that's kind of the idea, is you can either, when there's a coefficient of 1, just kind of do it straight away. But if it's more complicated, or if you just want to do it this way, you can always break up your middle term as the things that multiply to this times this, and then factor by grouping. It should always, always work. If, and it's a big if, it's not always possible, if you can find numbers that multiply to 1 times 12 and add up to 7, or in general, find numbers that multiply to the first thing times the last thing and add it to the middle thing. So let me see what else I want. So now we want to solve this. So we were trying to solve x squared plus 7x plus 12 equal to 0. So that's going to become x plus 3 times x plus 4 equal to 0. And just like we've seen with trig equations, when you have two things that multiply to 0, either one of the factors can equal 0. So either we can have x plus 3 equal to 0 or x plus 4 equal to 0. That's going to lead to x equal to -3 or x equal to -4. I imagine a lot of you can probably just jump to that last step. That's perfectly fine. I just want to show all the intermediate steps. So here are kind of the ways to make this work. If our equation, I should really say if our quadratic equation, because it is quadratic, because the highest power of x is 2, is ax squared plus bx plus c equal to 0, we need two numbers. Wow, that's a good M there, right? That's an excellent looking M. Two numbers, yeah, okay. Sure, we'll buy that. Two numbers that multiply to a times c and add to b. If we can find that, then we can do this process every time. Yeah. So let's look at some examples. We want to factor x squared minus x minus 6. Now I will point out, and so I just want to point out because sometimes people try and answer the wrong question. By the way, you guys like my sparkling water bottle? Yes, okay. So if someone said to factor this, they're not asking you to find answers x equal to something, x equal to something else. They're just asking for you to write the two things in parentheses. So someone said factor x squared minus x minus 6. I look for numbers that multiply to, thank you, yeah, my niece loves it too. My niece who is 4, 5, 4, somewhere in between. We need to multiply to, or I should say, we need to add to -1, multiply to -6. Well, great, I can find two numbers that do that. They are -3 and +2. So that means this factors as x minus 3 times x plus 2. Now, I know I kind of didn't do it the longer way, right? I could have also done it as x squared plus 2x minus 3x minus 6, right? I could have written the minus x as 2x minus 3x. Also, here's a tip. It doesn't matter which way you do it. You can do it as, well, in fact, I'll do it both ways. You can do it this way and then factor by grouping. From the first two terms, I'm going to get an x times x plus 2. From the second two terms, instead of factoring out a 3, I'm going to factor out a -3. I'm going to get an x plus 2. You're always trying to have that second group have the same leftovers as the first group. And then we can factor out an x plus 2 from each of these. And you've got an x plus 2 times x minus 3. It would be the same if we did it the other way. I should probably put some brackets around that. I could do it as x squared minus 3x plus 2x minus 6. Then if I factor out from here an x, I'm left with an x minus 3. I factor out from here a 2, I'm left with an x minus 3. And I can factor out an x minus 3 from both of those, and I have x minus 3 times x plus 2. So it literally does not matter which order you add to the middle term, right? Whether you do -3 plus 2 or +2 minus 3 or plus -3. It's going to work out the same either way. But I want to stress, if the question or the process is to factor that, then this is our final answer, whichever way you want to write it. On the other hand, if someone says to find, say, the roots of x squared minus x minus 6, that means they want you to solve x squared minus x minus 6 equal to 0, right? And those are different questions. Sometimes you might have to rearrange the terms. Yeah, so someone wrote, Sarah mentioned something you have to rearrange the terms. Usually you don't have to. Almost always you can get away with writing it either way, but occasionally occasionally some rearrangement might be required. But for this one, right, if we're solving an equation versus just factoring without it being equal to 0, then we're going to factor, I'm going to use the first one, x minus 3 times x plus 2 equal to 0. And you're going to do enough of this that you want to get fast at it. We know that we're going to say each factor can equal 0. So if x minus 3 is equal to 0, I want to be able to jump straight to saying, oh, that means x is going to equal 3. And this means x is going to equal -2. I'm kind of skipping, not kind of, I'm exactly skipping the step where I'm saying x minus 3 equals 0 or x plus 2 equals 0. And it's okay to skip that step. I would encourage you to skip that step. Just make sure you understand what's happening, right? And if you're not sure or get stuck, you can always go back and go like, well, I can set each factor equal to 0. Again, I want to stress the difference, right? This first question where I just said factor this, all we did was factor it. We didn't actually get any answers because there's no equation to solve for. Whereas this question where we said find the roots, find the solutions, then we had to solve this thing equal to 0 and we got actual answers for x. So just be aware, there is a slight difference in what we have to do depending on what we're asked. So let's do some factoring where we don't actually solve any equations. So we're going to factor the following. Oh, and yeah, I'm going to start off with one of my favorite examples. We're going to factor the following 4 things. We have x squared plus 5x plus 6. And then over here, we're going to have x squared minus 5x plus 6. And then down here, we're going to have x squared plus 5x minus 6. And over here, we're going to have x squared minus 5x minus 6. We're going to factor each of these. And so in each of these, I'm looking for things that multiply to a times c, right? If we're thinking of this as ax squared plus bx plus c. Right? Here we're trying to multiply to 6 and add up to 5. I know I've seen people do this like cool thing where they're like this and they're like, I have no idea. Like I'm like, okay, nope, I can't even pretend like I know what I'm doing. Anyway, you guys know it, probably have seen something like this before. I know nothing. Yeah, exactly. Right. I'm like, there's the people who are like, okay, I want to multiply to 6 and add to 5. So I'm like, I feel like you could do like 3 and 2 and they multiply to 6 and they add to 5. But I feel like there's other things people do there or something. Do whatever works for you. This clearly does not work for me, so I don't do it that way because my brain is just like, I never learned it that way. That's okay. You don't have to have learned it every way. You just have to have learned it the ways that work for you. So we are trying to multiply to 6 and 5, and that is going to be 2 and 3. So this is going to factor as x plus 2 times x plus 3. Or again, you could take the slightly longer route and say first, oh, it's x squared plus 3x plus 2x plus 6, and then it's x times x plus 3 plus 2 times x plus 3. And then the x plus 3's factor out, and you get x plus 3 times x plus 2. What I'm trying to emphasize here is that specifically when the coefficient is 1 of x squared, you don't have to do it this longer way. You can skip to just saying, oh, it's going to be just the 2 numbers we found. Excuse me. That's not always the case. It's not usually the case if your coefficient of x squared is something other than 1, which we will get to. So for this one here, x squared minus 5x plus 6, I'm trying to multiply the 6 and now to -5. Oh, that's going to be -2 and -3. So this is going to end up equaling x minus 2 times x minus 3. And hopefully you guys can see that, oh yeah, if I multiply this out, I'm going to multiply it back out because why not? I'm going to get x times x. I'm going to get x times -3. I'm going to get x times -2. I'm going to get -2 times -3. Oh yeah, that's exactly what I started with. In fact, it's written in the kind of factor or the grouping way, right? You could see that's why we do it this way, because if you then say, oh, I'm looking for numbers that multiply to this and add up to this, the -2, -3, I can definitely break that -5x up as -2 and -3. And then we could factor by grouping, which just gets us right back to there. I know I'm doing a lot of explaining of the same thing kind of over and over again, but it's kind of because this comes up a lot. Right, so you could do the factoring by grouping and say, oh yeah, it's x times x minus 3 for the first two things and -2 times x minus 3 for the second two things. And then you can factor out an x minus 3 and get x minus 3 and x minus 2. Okay, and then we have this one. So now we're trying to multiply to -6 and add up to +5. So I want +6 and -1. So I could write this as x squared plus 6x minus 1x minus 6. And then I could factor out an x from the first thing. And whenever there's negatives involved, you have to be a little bit careful. We're trying to get an x plus 6 left over from these second two pieces. So we definitely should try factoring out a -1. So we're left with a positive x. And then from each of these, we factor out an x plus 6. So we're left with an x minus 1. Oops, now I made a mistake there. I said equals 0. It's not, I mean, it is a mistake. I shouldn't lie. It's a mistake, right? Never in this problem did someone say solve this equation. So I shouldn't be writing that, right? I'm just trying to factor this, and this is how it factors. If I was setting any of these equal to 0, like this first one, if I was setting that equal to 0, the solutions would be -3 and -2. And if I was setting this one equal to 0, the solutions would be +2 and +3. If I was setting this one equal to 0, the solutions would be x equal to -6 and x equal to +1. And this one, I'm looking to multiply the -6 and add to -5. So I want -6 and +1. And this is going to factor as x minus 6 times x plus 1. And what I want to mention with these 4 examples specifically, because they come up frequently, is that whenever you have x squared plus or minus 5x plus or minus 6, it always factors. And it always factors in one of these 4 ways. But it can be easy to accidentally get the wrong one. So just be careful when you're doing these, right? You can get different answers depending on, not different answers. You can easily get the wrong answer if you're not being careful. So really make sure you're paying attention to the sign. Right? I want these numbers to multiply to -6 and add up to -5, and so on and so on. All right. And we could go on, right? Like we could look at something like, in fact, I want to do these 2 examples. So let's look at x squared plus 2x minus 8 versus, and again, we're factoring still, we're just factoring, versus x squared minus 2x minus 8. So here's something nice. How did you factor the 2 box on top? 2 box on top. Oh, wait, you were, never mind. Oh, wait, no, it's okay. Which one are you talking about? I'm not the 2 box. Top right, okay. So this one, right, I was looking for numbers that multiplied to +6 and added up to -5. And that was definitely -2 and -3. Because -2 times -3 is +6. And -2 plus -3 is -5. That's how I did that one. And that's kind of always what we're doing. We're looking for numbers that multiply to, and now you should notice I'm kind of ignoring the 1. Really, I'm looking for numbers that multiply to 1 times 6 and add up to -5. It's just that when there's a 1, you kind of ignore it. Something that we saw in the last examples, and we'll see in these examples as well, is if everything except for the middle term is the same, and the middle term is just an opposite sign, the factoring is virtually the same, except 2 things are switched. So this one, I'm looking for numbers that add up to 2 and multiply to -8. So I don't want to write anything like that really. I just want to say, okay, what multiplies to -8 and adds up to +2? It's going to be a positive 4 and a negative 2. Or again, we could go the long way. We could say we know it's 4 and negative 2. And then we could write it as x squared plus 4x minus 2x minus 8, right? So that the middle terms here add up to 2x. And then we could factor by grouping. And say, oh yeah, that's going to be x times x plus 4 minus 2 times x plus 4. And then if we factor out an x plus 4, oh yeah, we're back to here. We have an x plus 4 left over an x minus 2. What I want to mention is if you change the middle sign, all you're doing is changing the signs of these, because now you're trying to add up to negative 2 instead of positive 2. So you're looking for we want a negative 4 and a positive 2, right? The opposite signs of a positive 4 and a negative 2. So if you have factored something and then you're trying to factor the same thing, and the only thing that is changed is the coefficient of your middle term, of your b, if you like, then all you're going to do is change the signs of these, and you're going to get that this is equal to x minus 4 times x plus 2. For me, when I'm mentally checking if I factored correctly, I usually only have to check the middle term because I know that the ends work. I know that x times x is definitely x squared. I know that negative 4 times 2 is definitely negative 8. But the middle terms, you have to add them together to check. So I'm like, okay, well, let's see. Negative 4 times x is a negative 4x. And x times a 2 is a positive 2x. And that 2x and that negative 4x definitely add up to negative 2x, which is what I want. So if you're trying to like check to make sure you've done it right, that's usually the first thing I'm checking is, do the middle terms actually add up to the right thing? And then it kind of starts to get old if we don't do something more complicated, right? You could look at something like x squared plus 8x plus 12, and you're trying to multiply to 12, okay, and we're trying to add to 8. I think 2 and 6 are our candidates. Now, again, since 1 is leading coefficient, we could just jump straight to saying it's x plus 2 times x plus 6. But you could also take the intermediate step of saying, well, I'm going to do some factoring by grouping, James. I'm going to do is x squared plus 2x plus 6x plus 12. Right? Again, we're just rewriting the middle term as the sum of two smaller terms, and the coefficients have to multiply to 1 times 12. And then we factor by grouping. This becomes, I should point out, I know I've said factoring by grouping a couple times. When you're factoring by grouping, you're just taking pairs of things. So to factor by grouping, you have to have an even number of terms. In this case, 1, 2, 3, 4. You group the first two together, you factor out the largest common factor, which in this case is x. And you take the next two terms and you do the same thing. You factor out the largest common factor, which in this case is 6. And then from these two, they each have a factor of x plus 2. So you factor out the x plus 2, and then the leftover part is the x here plus the 6 there. And you get x plus 2 times x plus 6. And again, I'll mention, right, none of these factoring problems have solutions. Right? We're not setting any of these equal to 0 because the question just said to factor. But if we were setting them equal to 0, the solutions here would be x equal to negative 4 and positive 2. The solutions here would be x equal to positive 4 and x equal to negative 2. And the zeros here would be x equal to negative 2 and negative 6. Always, well, I don't want to say that actually. And then one more. We could do this x squared minus 8x plus 12. And that would factor in virtually the same way, except the signs here are going to change. So it's going to factor as x minus 2 times x minus 6. Because minus 2 and minus 6 multiply to positive 12 and add up to negative 8. So factoring with trig functions is a good question. So if I wanted to factor something like cosecant squared of x minus cosecant of x minus 2, and for those, right, this is someone asked me this question in the chat, how would you factor something like this? You can do it kind of two different ways. One way is to just kind of well, people do what's called a U substitution, where they replace the cosecant or whatever the trig function is with just an easier variable to work with. So some people will be like, I'm going to let U equal cosecant of x. And then I'm going to rewrite this as U squared minus U minus 2. And then it's the same process. We say, okay, well, I'm going to try and multiply to -2 and add up to -1. So that's going to be, let's see, if I want to multiply to -2, there's not really a lot of ways to multiply to -2. It's either -2 and +1 or +2 and -1. In this case, it's got to be -2 and +1. So we're going to get U minus 2 times U plus 1. And then you replace the U with what it's actually equal to. So this then becomes cosecant of x minus 2 times cosecant of x plus 1. You can skip the U substitution if you want, right? A lot of people just feel like, oh yeah, I'm just pretending that cosecant is my variable and factoring in that way. And then if you were trying to solve this equal to 0, you would say, okay, cosecant of x minus 2 equals 0, or cosecant of x is equal to 2. And cosecant of x plus 1 is equal to 0, so cosecant of x is equal to -1. And then I'd probably talk about sine, right? If cosecant is equal to 2, sine is going to equal 1/2. And if cosecant is equal to -1, sine is going to equal -1. Yeah, great question. That's definitely kind of right on topic. Excellent question. So now let's solve some equations. And again, the only difference between factoring and solving an equation is when you're solving an equation, you're actually being asked to set something typically equal to 0 and then find the solution. So let's say we want to solve the following. X squared plus 5x plus 4 equal to 0. There was something I was going to say here. Maybe not. I don't know. I guess not. Oh, I know. You can solve these however you want. Typically, my go-to method is factoring if I can easily, and then usually the quadratic formula if I can't. I don't usually mess around with anything else, although there are other methods that work. This one I am going to factor. It's going to factor as x plus 4 times x plus 1 equal to 0. And then I don't think you need to show this step, but you certainly can, where we set each factor equal to 0, and then we get x equal to -4 or x equal to -1. Those are solutions. That's pretty much it. Let's look at another one. Let's change it up just slightly. Let's say we were starting with x squared plus 10 equal to 7x. So when you have a problem like this, or whenever you have a non-linear equation, meaning x is raised to some power other than 1, you almost always want to bring everything to one side and set it equal to 0. So I'm going to subtract the 7x, and I want to write it in the standard form. Right? I want to write x squared minus 7x plus 10 equal to 0. I don't want to write like x squared plus 10 minus 7x equals 0. That would be silly. And then we factor. I'm looking for things that multiply to 1 times 10, which is 10, and add up to -7. Well, there's really only one choice. -2 and -5. Those are the things that multiply to +10 and add up to -7. And then we get x equal to +2 from that factor, x equal to +5 from that factor. Is it nonlinear because x1 makes the graph not a straight line? Yeah, essentially, yes. Nonlinear, so a linear graph will just be something like y equals 3x plus 2 is linear. But anything else is going to be nonlinear. So like y equals x squared minus 3x minus 10 is nonlinear. Or y equal to 5 over x minus 1. Even though technically you might think, oh, I don't have x to a different power than 1. Technically you have an x to the -1 power, which is not the same as +1. So, I mean, really this is technically 5 times x minus 1 to the -1. But all things being equal, right, it's still nonlinear. So yeah, nonlinear, the graph is not a straight line. And the function or the equation will have powers of x or maybe not, like sine of x is also nonlinear. Anything that doesn't have just x to the first power or a constant is nonlinear. Okay. So, yeah. A lot of examples. Sure. Let's look at a couple more examples and then we'll move on. So if I was trying to solve something like x squared minus 5x equal to 24, what I really want to stress is you can't factor this yet. You can, but it's not going to work out. If you try factoring this right now as x times x minus 5 equal to 24, you might luck out and get one of the answers, but you probably won't. The wrong thing people usually do here is they say, oh, x equals 24 or x minus 5 equals 24. And that's not right. Because if you say x equals 24 and you plug that back in, you get 24 times 24 minus 5. And that is definitely not equal to 24. So before you ever factor, you almost always want the thing to equal 0. So instead, we're going to say x squared minus 5x minus 24 equals 0. And then we're going to factor x minus 8 times x plus 3. Because negative 8 and positive 3 multiply to negative 24 and add up to negative 5. And then our solutions are x equal to 8 and x equal to negative 3. I will also point out, sometimes it's too easy. You guys are like, give me that. Like if you want to solve x squared equal to 6x. The wrong thing to do here is to divide by x. Because if you divide both sides by x, you get x equal to 6. Now, I will say it's not entirely wrong. X equal to 6 is one of the answers. But the problem is x equal to 6 is not the only answer. We should factor, meaning we should first set it equal to 0. X squared minus 6x equals 0. Now, in this case, there isn't a constant term, right? There's nothing we want to kind of multiply to and then add up to, right? We technically want to multiply to 0 and add up to negative 6. I mean, I guess that actually is true. We do want to multiply to 0 and add to negative 6. Well, I can think of two numbers that do that. 0 and negative 6. Those numbers multiply to 0 and add to negative 6. I'm doing way too much work, right? The easy answer is just, hey, each of these have an x. Factor out an x. But if you really want to think of it this way, you could really think of it as x plus 0 times x minus 6. That is also technically correct. Just not necessary, right? This is definitely the way to go. And then we say, oh, we get x equal to 0 and x equal to 6. So I'll point out there are a lot of examples in the notes that, as usual, I'm not going to get to all of them because I've just written too many examples in my notes. That's fine. They're on Canvas. You can see them. They're the old notes. I do want to start talking about the examples where you have a coefficient of x squared that is not 1. Let's look at something like two x squared plus 13x plus 15. So now it's a little trickier. You want to find numbers that multiply to 2 times 15, which is 30. The numbers might be 2 and 15. That is sometimes an option. And add up to 13. All right, so what are two numbers that multiply to 30 and add up to 13? If it was a negative 30, negative 2 and positive 15 would totally work because it's after 13, but it's not, it's positive 30. So let's see. I think 3 and 10 work. So then I'm going to take x squared plus 13x plus 15, and I'm going to rewrite it as x squared plus, I don't care which order. You can either do 10x plus 3x or 3x plus 10x. Either way will work. But what's important to notice, right, is that literally it's the same thing. It's just that 13x is this 10x plus 3x. And I forgot something super important though. I didn't write the right thing down. I forgot the 2. That was important. And then we're going to factor by grouping. From this first factor, I can factor out a 2x, and I'm left with an x plus 5. From this second factor, I better be left with an x plus 5 after I factor out whatever I can factor. And I am. If I factor out a 3, I'm left with an x plus 5. And then from each of these larger pieces, I can factor out an x plus 5. From this piece, I'm left with a 2x because I've already factored out the x plus 5. And from this piece, I'm left with a 3 because I've already factored out the x plus 5. And that's it. That's my answer. 2x squared plus 13x plus 15 factors as x plus 5 times 2x plus 3. And that's how we generally approach factoring something that's more complicated with a coefficient on x squared that is bigger than or different than 1. Yeah, so there's a lot of the notes on this next, like I'm just looking at my own notes. I'm like, a lot of the notes are talking about how to do the factoring by grouping for the easier examples, which we already did. So let's just do some more hard examples. Yeah, let's go ahead and do that. So now I want to solve. Now let's make it not so silly, James. Let's solve 3x squared plus 7x minus 6 equals 0. How come we don't factor out the coefficient in nonlinear inequalities, even if it's possible to do so? I don't know. I would. You certainly can. I don't have a good answer to that off the top of my head, other than I think you can. That's definitely not. So we will, I think we'll talk about nonlinear inequality at some point, but we're definitely talking about just solving equations right now. So happy to address that question more in office hours, but I don't know if there's a good answer to that question off the top of my head without looking at some specific examples. So here we want to, I'm going to write that, right? Whenever I'm writing this down, I'm always thinking of the coefficient of x squared is a, the coefficient of x is b, and the constant term is c. So I'm really thinking of like, this is a equal to 3, b equal to 7, c equal to -6. Even if I'm not actually ever writing that down, my brain is always thinking that. So I could not write this down and still write something like a times c equals 3 times -6 equals -18. And all of us would know what we were talking about, even if we didn't write down the red part there. If I wrote that down or you write that down, be like, oh yeah, cool. We all are on the same page. And then we also know that our b value is +7. So we're looking to multiply to this and add to this. So, okay, yeah. So sometimes it's challenging, so I will point out, sometimes it's challenging. Sometimes it is literally impossible, right? You might try to do something by factoring and get stuck because it doesn't factor. I will never ask you on purpose to factor something that doesn't factor. I might ask you to solve something that doesn't factor, but then you would use the quadratic formula if you couldn't factor it easily. So if I start trying to factor something, I'm like, I don't know if it works. I just jump to the quadratic formula, which we'll talk about tomorrow. This one, we certainly can find numbers, right? -18 is equal to 9 times -2. And 7 is equal to 9 plus -2. So we found two numbers that multiply to -18 and add up to +7. Great. So then we take our equation, 3x squared plus 7x minus 6 equal to 0. And we're going to factor the left-hand side by grouping. Now, it doesn't matter which thing you put where, but sometimes it seems like there might be a more obvious choice. It might feel smarter to put the 9x first. So the 3x squared plus the 9x, you can factor out a 3x. But it literally doesn't matter. If instead I do the -2x first and the 9x second, it'll still work out. Also, here's a tip. If you have a choice between putting the negative thing first or second, like if you have a negative and a positive, it's usually actually easier to put the negative thing first, because you don't have to worry about how to factor the second thing the right way. You'll always get it right. So from these two pieces, all I can factor out is an x. I'm left with a 3x minus 2. From these pieces, I can factor out a 3. And I'm left with, oh good, a 3x minus 2. Otherwise, I'd be in trouble. And then from both of these, I can factor out a 3x minus 2. And I'm left with an x plus 3. So I'm solving 3x. I'm going to write it again because this looks kind of not great. 3x minus 2 times x plus 3 equal to 0. Which is going to lead me to either 3x minus 2 equal to 0 or x plus 3 equal to 0. This one's pretty easy, right? We just subtract 3 and get x equal to -3. This one you have to do a little more work for. 3x equals +2. Divide both sides by 3 to get x equal to 2/3. I will point out or admit, I don't know, I will admit, I used to prefer factoring something like this by the guess and check method, which is not terribly efficient, right? I would have done this problem in a previous lifetime as, well, in fact, I'll just show you my work instead of trying to do it because I don't want to waste your time really. But I would have done this previously, been like, okay, well, I'm looking for numbers that multiply to -6, and add up to, well, actually, so not multiply to negative. Well, so that's where it gets confusing, right? It's a totally different method. If I was trying to do it this other way, I would try to be multiplying to -6 and then make the middle terms add up to 7, but with this 3. So it's definitely challenging to do it this other way. So I would say, even though I used to prefer the guess and check method, it's not the best. It's not the most efficient. It's not the most algorithmic, right? It's not a very well-defined process. It's just kind of like, oh, we're going to try something, and we'll try something else, and we'll try something else. That said, if the guess and check method works for you because you're really fast at multiplying and adding things, you should do what works best for you. That's kind of not my only mantra when it comes to math, but definitely one of my mantras is if the thing you're doing is right and it works for you, even if it doesn't work for everybody else, that's okay. As long as it's not incorrect, right? You're not doing the wrong thing to get to the right answer. As long as you're doing the right thing to get to the right answer, even if it's totally different than what everyone else is doing, that is really okay. I suppose some exceptions to that are specifically if someone says, please do this question this particular way. Generally, I try to avoid doing that, but I know there was one test question where I did ask you to do something in particular way, like an angle sum formula. And I think a couple people did do it a slightly different way. I was like, well, okay. So let's look at another one. I want to solve 3x squared plus 8x equal to 3. And again, I will mention, if you do look at my old notes for this problem and the previous problem, I did them a very different way. I think I did them both ways, but definitely I wrote a whole lot because I did this whole guessing and checking thing, which again, I would really kind of encourage everyone not to do. I don't think it's the best anymore. I used to like it better. I don't anymore. I've evolved. Good for me. So again, first things first, we want to set this equal to 0. So we're going to subtract 3. So 3x squared plus 8x minus 3 equals 0. So my a times c is -9, and my b is equal to +8. I would really encourage everyone to make sure you write the signs. write the positives, even though it seems kind of silly, just to kind of really strongly differentiate because, oh yeah, if this one's positive, I know it's positive, and if the other one's negative, I'm also making sure of that. So I want to add up to positive 8. I want to multiply to negative 9. Whoops. I want to not get pen all over myself. So I'm thinking 9 times negative 1. Or I'm thinking 9 plus negative 1. That works. So then we're going to rewrite this equation as 3x squared. And I'm going to take my own advice here. If I have a choice between writing the negative thing first or the positive thing first, I'm actually going to choose to write the negative thing. Again, it actually doesn't matter. Either way will work. So I have 3x squared minus x plus 9x minus 3 equals 0. And I'll just, again, reiterate, this part here is equal to 8x. So we haven't really changed anything. We've just written it in a slightly different way. And then we're going to factor by the grouping. We get x times 3x minus 1. We get 3 times 3x minus 1. And then from each of these, we factor out the 3x minus 1. And we're left with an x here and a 3 there. So then we either get 3x minus 1 equal to 0, which leads to 3x equal to positive 1, x equal to 1/3, or x plus 3 equal to 0, which leads to x equal to negative 3. Those are my solutions. What time we got? We got time for one more. There are a couple other examples in the notes that we won't get to. If you're looking for more examples, they're certainly there. There are lots of examples in these notes. So there's like 2 more examples. Yeah, they're fun. Let's do, this one looks, try that one. That one looks exciting. Let's try this one. 6x squared plus 5x equal to 6. I will often write things not equal to 0 just to remind you to set them equal to 0, right? So the very first thing when you're solving these quadratic equations is to set it equal to 0 every time without a doubt. Even if it's something easy like x squared equal to 9, okay, you could probably just say that's x equal to plus or minus 3, but you could also do it as x squared minus 9 equal to 0, and then x minus 3 times x plus 3 equal to 0. Right, in this one, you're trying to multiply the negative 9 and add up to the middle term, which is 0. And the negative 3 and the positive 3, multiply the negative 9 and add up to 0. So here you get. So I will stress, for quadratic equations, you really should factor. Even if it's super easy like this, it still would encourage you to factor. Okay, I know it's 2:20, but let me bust out this last one just so you can see one more example, and then I'll be done with the class. And then you can ask other questions. So 6x squared plus 5x minus 6 equals 0. Our a times our c is 6 times negative 6, which is negative 36. And our b is 5. All right, so we have to multiply to this. And we have to add up to this. Okay. So if we're multiplying to a negative, that means we have to have a negative and a positive. And if we're adding up to a positive, it means the positive one needs to be bigger than the negative. So let's see, negative 36, I've got, so you might just start making a list. Negative 1 and 36, nope. So I'm always going to think of the things that multiply to the thing and then see if they add to the thing and equal to. That doesn't work. It does add up to 35. Negative 2 and 18, nope, that's add up to 16. Negative 3 and 12, that adds up to 9. Negative 4 and 9, that adds up to 5. Oh, there we go. Negative 4 and 9. So I'm just listing the things that multiply to negative 36 and seeing if they add up to what I need them to add up to. And that's the process I've been using this whole time. It's just most of them were easier to see than this one. So then we're going to rewrite this as 6x squared. I'm going to choose the minus 1 first. Minus 4x, not plus 5x, plus 9x minus 6 equal to 0. And then we factor by grouping. I can factor out a 2x from here. I'm left with a 3x minus 2. I can factor out a 3 from here, and I'm left with a 3x minus 2. And then from each of these, I can factor out the 3x minus 2, and I'm left with 2x plus 3. Still equal to 0. So then I either get 3x minus 2 equal to 0, which means 3x equals positive 2, which means x equals positive 2/3, or 2x plus 3 equal to 0, which means 2x equals negative 3, which means x equals negative 3/2. And those are my two solutions.